if you have a coterminal angle, those are angles that stop in the same position. They can be written with a value between 0 and 360 or 0 and 2 pi. So if you have the 250 and you subtract 360 from it, you can find its coterminal value. You're basically adding or subtracting 360 degrees to get rid of the extra rotation and find out, hey, if I had something that rotated 450 degrees, all that's really saying is I go all the way around and then I go an additional 90 degrees, and that's the same thing as this whole thing, which would also be 450. So you're basically just getting rid of the extra rotation to figure out actually where does that actually land, because any angle can be written so that it lands somewhere between 0 and 360. Even a negative angle like 120, I could always add 360 to that and find out, hey, going negative 120 or going back around this way about 120 is the same thing as going a positive 240. So negative 120, positive 240, exactly the same angle. If you get something really big like 800, you might have to subtract 360 once. And the first time you subtract 360, that would get you down to 440. And you're like, well, that's still too big. Well, you're right. It is bigger than it needs to be. So I'm going to have to subtract 360 again. And basically, I find out that that had 2 complete rotations. So if I were to graph that, it would have gone around once, twice, and then it would have gone an additional 80 degrees. So something about like that. But if I just would have rotated 80 degrees, it would have been a lot simpler to get to the same place. I can use the same trick with radians. Something like this. I could add pi over 2. I don't have to convert it to degrees. Remember, adding 2 pi is the same thing as adding 360 because they're both one rotation of the circle. If you're putting that in Desmos, remember, if you want pi in your answer, don't put it in the calculator. So just do negative 4/3 plus 2 would be 2/3 or 2 pi over 3. A lot of times, by the way, 2/3 pi and 2 pi over 3, exactly the same thing. A lot of times we just make the habit of putting that pi in the numerator. And then the last one, if I have a 5 pi, that's bigger than 2 pi, so I'm going to subtract 2 pi, and that's going to leave me with a 3 pi. That's still too big, so I would subtract 2 pi again, which will leave me with a pi. And just to show you, if I were to graph that one, 2 pi would mean I would be going all the way around. Another 2 pi means I would be going all the way around again. And then my final pi would mean I would be going halfway around, because if 2 pi is all the way around, pi is halfway around. And while we're at it, if this is pi, straight up would be pi over 2, which is the same as 90 degrees. And halfway between pi and 2 pi would be 1.5 pi or 3/2 pi or 3 pi over 2. So that's how you can label your axis with radians. If all the way around is 2 pi, halfway is pi, and then half of 1 is pi over 2, and then 1 plus a half is 3/2 or 3 pi over 2. So that's how you can also label an axis during radians. You could always convert to degrees to figure it out if you wanted to, but it's not necessary if you have the idea of what a radian is.